then we'll have a problem. So we have just like 3 slides, and then we'll start on stoichiometry. So another type of reaction, and it is a redox reaction. So it's not really new. It's just another way to describe a redox reaction. It is called a displacement reaction. In displacement reactions, ions oxidize an element. The ions then are reduced. All right.
So how is this different than?
It's not. It's just a different. It's another name of pretty much the same thing. So sometimes this is also called a single replacement. So when I was a kid, my name was Tom. Yep, it's been completely replaced with Dave's. But anyway, Tom, I dated a girl named Shannon. And then I had a best friend named Andy. Close to tense, by the way. Just kidding.
No shade at Andy.
Andy and I, we communicated just like 3 days ago. All right. I went on a trip for Christmas to visit my dad in Colorado. While I was away, some things happened.
Oh, shoot.
That's
I think I know where this is going.
Yeah, so I
Andy
came
got
back.
that opportunity and he took it.
Yeah, I came back and now Andy and Shannon were together, and I was over here all by myself.
Now I understand.
What's that? It was sad.
Is that what you
Yes. But it was all right, because then I realized I never wanted a girlfriend ever again. I just wanted to be hanging out with girls, but not an individual one. So it worked out fine. So now these two eventually broke up. But in a displacement reaction, the thing that's alone will replace one of the things that's together. And the thing that's together comes out on one side and it's alone.
Well, then you just do it. Flip the then you're happy.
Yeah, all I need to do is reverse it. Yes.
How does it choose which one?
All right. In chemistry, it's the charge. This is the plus, this is the minus. Over here, this will be the plus, this will be the minus. So,
So really you just gotta look and see what the
yeah, you need to know if the A is a metal or a non-metal. The metal, it goes at the start. Non-metal, it goes at the end. Okay. So this is an example, you can't tell it, but this is an example of copper wire, copper mesh actually, in silver nitrate. So I have copper that's a solid. I've added it to AgNO3, which is aqueous. Then, what's going to replace what here? Good. Copper is going to replace silver. All right, so I get Cu, this would be NO3 2, plus Ag solid, this would be aqueous. So we look up here, and this doesn't look like copper. What does it look like? It looks like silver, because the silver solid is stuck to the copper wire. Okay. The next one, I did. Thank you for checking. You got that little like beating red dot. Okay. That's just the same thing we've been doing. It's a redox reaction. It's just another name. So here's the exact same example again. We have the copper wire. We put it in silver nitrate. And then this one it's gone on longer. You can see the solution maybe. You can see it started to turn blue because it's still over time. Solutions that have a copper ion in them, they'll turn blue.
Isn't that why the Statue of Liberty is green now?
Well, not that exact science, but copper, when it oxidizes, it makes copper oxide, and that's green. So, I mean, it's pretty similar, but this one's blue versus green. Okay, so we would call it a double replacement reaction. Would you tell me, not a double, sorry, single replacement? Will you tell me the element that's oxidized, well, actually tell your partner, and the element reduced? All right. So I have copper. Is it becoming more positive or more negative? More positive, which means it lost electrons. No, it's oxidized. Leo says true. Silver went from positive to neutral, which means it must have become more negative. So it gained. Okay, with that?
Oh, I see.
Now this is the net ionic equation as they written it. They got rid of L3 because it's a spectator always.
Oh, is that, on top of that plus 2 is supposed to be up?
Yep. All right. Good?
Yes. E.
All right. This is the same thing. So here we go. This is important. You need to know what the activity series is and how to use it. That's why we're doing this little sliver. I thought we were good enough, but I forgot about this. So you on a test question will often be given this type of picture, and it's called the activity series. And you can use it to predict whether a reaction is even going to happen between a metal and a solution. So please make sure, if you're a note writer, to put this in your notes tied to this term. In order for a reaction to proceed as written, meaning from the left to the right, the lone element must be higher on the activity series than the element written as an ion. So, in order for this reaction to have actually happened, the lone element, that's the solid, had to be higher than the ion that it's reacting. Because if the equation said Ag solid plus Cu NO3 2 and an arrow, that reaction would not work. Because copper doesn't have the ability to make silver, to oxidize silver. According to this, all right, it's harder for silver to be oxidized than copper. So silver can tell copper what to do, but copper can't tell silver what to do. Yeah.
So it's not like usually like on a test cell or something like it's not kind of like a given, like so we're not, I don't know, are we gonna have to write one out?
No, a test question like this would look exactly like the question coming up. I'll go back. So write this down because you're going to apply this on the next slide. Go ahead.
So this would be like how Andy could always steal the girl from you,
Yeah, we would
but you
say-
could never steal the girl from Andy.
Yeah, it's definitely not true, just FYI. But yes. But yeah, if Andy wasn't richer and better looking, he probably wouldn't have been able to steal my girlfriend. But unfortunately, he did have those two things. Now, by the way, we're 44. He's still richer, but he is definitely not better looking. I still have all my hair and a decent body. So,
And a good
Oh,
diet.
you don't like Andy.
no, Andy and I are, he's the only one of two people I still contact with.
Wait, does
Are
Andy
you
not,
still your girl?
His wife, It was like,
Andy's very weird. Does Andy not have a decent lobby?
he doesn't anymore.
That's it. Someone find Andy. We're gonna call him over.
I wanna meet this.
Andy, well, look, we could have all met Andy, but our Murray football game got canceled.
Oh, it did?
Yeah, his daughter's a cheerleader for Murray High.
Oh.
So whenever we play, we always got to dinner and then go to the Yankee overtime. Thanks, COVID. 2020 sucks. Yes, Judah.
So when you touch copper, is the bulb silver? It
Then the reaction will happen.
right. So but silver was above copper.
Correct. Right. So this right here says ease of something. It's so blurry. That doesn't make it.
Are you going blind?
Ease, no, this is blurry. Ease of oxidation reactions. So what we're saying is, remember, oxidation means you're a really good loser, or oxidation means you lose. So lithium would win the prize of the biggest loser.
I love that show.
Every single element out there can make lithium. It can steal electrons from lithium. But what we're saying is silver can steal an electron from copper, but copper cannot steal an electron from silver. Look at these right here. Tell me what these, ignore mercury for just a second. What do gold, platinum, silver, and copper sort of have in common?
Or a metal?
Well, everything can
They
go.
conduct electricity.
So they conduct electricity, we're not there yet. Okay, they're called the noble metals. We make jewelry out of those things. Anyone know why they make jewelry?
Because that's right.
Pretty, you don't oxidize.
They're pretty and they don't corrode. They can't, gold cannot be oxidized. I've had this ring for over 20 years now, and all it has are scratches. It's not tarnished, it's not anything, because there's no other element that can make gold lose its electron.
Wait, so we're talking about this platinum, gold, not copper, silver,
Copper and silver, they are jewelry also.
or like they corrode and stuff, right?
They can, they take a lot longer. Like the Statue of Liberty, yes, it's green, it's been oxidized, all right, but not by any of those things on there. It was oxygen, which is a good oxidizer. Whoops, yes.
So, yeah, I just kind of got said, if you use USB 3, take that off and it's no longer attached.
Yep. Wouldn't happen. All right, Reese, did you still have a question?
No, I'm good, thank you.
Okay, so here we go. Looking at here, try these four. So the following, will the following reactions happen as written? And this is exactly how you'll see it on a test. It gives you the solid, this will be the solid, and then a solution, there's your ion. So hopefully you wrote down what you just said on the previous slide. Try these, try one, and talk to your partner, they try the other, let's go through it.
Wait, do we get the activity thing of our tests or no?
Yeah, if this was a test question, you would have that.
Okay.
I have them actually sitting right here. This is where I put the things that I pass out when you do a test. Oh, I need to tell you, sorry. Hydrochloric acid, it's not a metal, but it's the H plus ion in the acid. So this is where you compare. Okay, so it's the H plus versus the Ag solid. So that's saying, will the acid react with silver?
Yeah.
Hold on, I can't.
Is nickel better than copper?
So if the first, if the solid is
No, Oh, yeah.
If it just says like.
Silver's
metal,
Silver's the low.
You see how high that is?
You want me to bring the thing back over? You can take this.
Well, no, I think that was just a.
Oh, it's all.
Hydrogen.
Wait, which one is the lone element?
That's the solid.
Solid.
Okay,
Oh, yeah, acidity to your wall. The one from me, I was thinking like the one like. Chlorine super high.
No, like it's related to it, yes, that's for sure. We're comparing metals, so we're looking at, they're all pretty low. So yeah, they're related. All right, you're not ready?
I think so. I have one like that.
All right, I will give you another second. Long enough for you to walk over and get
All my money on it.
Used to be gas and shoot, wait a minute. How do they know where sulfur is?
Well, it's an acid that's hydrogen. You just don't see the hydrogen. Calcium is higher than sulfur.
whatever.
It has to be
It has to be gas. Where the fuck's sulfur? No,
Sulfur isn't the important part of hydrogen.
I know, forgot it. Figured it out.
Yes, I understand.
No, I figured it out right after.
Yes, sir. Yes, sir.
So,
I think so too.
All right, here we go. I'll walk over here, right there. All right, so nickel, let's clear this all out. Nickel is right here, right? Oops, that's not mine. Versus copper ion. Okay, so nickel solid and copper ion. In order for the reaction to proceed as written, the lone element must be higher. Is the lone element higher than copper?
Yes.
Yes. So does this happen as written? Yes. Okay, we have H plus versus Ag. Is the lone element higher than hydrogen?
No.
No. So number 2, no reaction. Who's 2 for 2 so far?
I'm winning.
You don't even know if you're 2 for 2? We're trouble. Okay, here we go.
Sometimes it's hard to count.
Chromium metal. All right, so this is my solid. Aqueous of cobalt. All right, so is my lone element higher? Where is chromium? Right here. Is it higher than cobalt?
Yes.
Yes. So does this happen?
Yes.
Yes. Calcium is added, so calcium is my solid. Is added to sulfuric acid, so that's hydrogen again. So we're comparing this one and this one. Will this reaction happen?
Yes.
Yes. This one's like super reactive. Okay, because there's a large difference. Anything towards the top here, very reactive, meaning easily oxidized. Anything down here, very non-reactive, meaning not easy to oxidize. Okay, so make sure you remember that piece. That's the very last part of reaction types. There's a lot of stuff in there. I hope you took notes so that you actually study them. Now, we're going to move on to one of my favorite parts of the year and some people's least favorite part of the year. And it's math.
I prefer math over chemistry. All you do is
Most kids, this is math with chemistry.
ah.
The which
Lots of
hopefully sounds more fun than just math or chemistry, right? What can be better than your two hardest classes combined? Okay, quarantine, you're probably right. All right. Speaking of that, I decided I have to have the best immune system ever. Almost everyone I run into in my life, someone has been positive. I just keep talking bullets like crazy. And then
Maybe
like,
you've had it and now you're just immune.
I wouldn't be surprised. I really wouldn't.
Yeah,
I had a test earlier in the year and I was fine. I was just sick, but this is fun. All right. This little link right here, this made me happy. You know, I did the screen, I'm sure. All right. This doesn't happen very often when you're a chemistry teacher because most kids forget about you because they've been trying to block out the nightmares. But it said, first semester of my PhD, I'm still using the picket test method for dimensional analysis. Thanks, Mr. Davidson, for the lessons that have proven to be invaluable. Clicking over on this picture. So, dimensional analysis, I call the picket test. It is the process of lining up terms and units so that you get only the unit you want in your answer. He could have put these also in there. It's the same process. So if you have a 20 megawatt power plant, how many homes get power, assuming the capacity factor 0.6 and an average home uses 1,200 kilowatts per year, whatever. You know, this is a process. If it clicks, you can use it in all sorts of things. This girl's a math. She has her master's in mathematics. You can do Jace Wilding, that's his older sister. She's chemistry quite a bit. She's a minor in chemistry. You know, it is a useful tool. Some people hate it and it never clicks. Some people hate it and it did click. And some people, they love it. They're like, this makes so much sense.
I love it and it just never looks good. That's kind of sucks.
It happens.
Why did you feel like that sometimes?
One time I had a girl bring me a dozen gigantic cinnamon rolls from Meters. And I said, Megan, I haven't seen you forever. What are you doing? And she's like, I brought you these because I'm grateful that you taught me how to do the picket test. I'm like, what? And she is the head baker for Meters in Salt Lake City. And when they hire chefs, the first thing they do is teach them how to up or down scale recipes. And they use dimensional analysis. This exact same type of thing. In your college science classes, they love questions like this. This is not really an applicable question very often unless you're just, you know, mega power plant owner that wants to know. But they want to see if you can think and do math in multiple steps. So, you know.
Funny, he did it in pen.
He did it in what?
He did it in pen.
I like
Don't make mistakes, you don't need to write.
I don't think that you can.
I don't know. He came before COVID last year and they talked about the things he was studying. And then like 2 or 3 months later is when we shut down. And I was like, wow, he's kind of actually doing a crap. That is like cutting edge on this stuff. So, you know, I promise you, it is a useful thing. All right, so plan for today. Stoichiometry, also known as fences. Stoichiometry is a fancy word for saying we are going to apply math to a balanced equation to calculate unknown values if we are given at least one of the masses or moles of any species involved in a reaction. That was fun to say. Species means any of the chemicals or ions involved in a chemical reaction. Picket fences are a tool to systematically align your numbers and units to convert from a given number and unit to an unknown unit, number, and unit. I think I screwed that up. Picket fences take advantage of the mathematical fact that anything that is on top and the bottom of a fraction can be eliminated from the problem. Okay. You don't need to write down every single word on there.
Why does math feel like it's cheating sometimes?
Math? I don't know.
Because like you can just cancel things out instead of actually
That's my favorite. That's what I love about math most.
Yeah.
Just cancel everything out and then it'll work.
Exactly. Nothing feels better than going like this. And not having to do any of this work. You're like, okay, math is actually useful for these problems. Okay, so here we go. Here is an example. If you would please work through it with me, it will hopefully make sense. So I don't know why I use this dumb font. Well, I do know. I only have 2 fonts that it chooses, and this is one of the 2 on that. So a typical question, and you guys will get harder questions in this, but this is a good start. It says, how many grams of salt can be formed if you have 36 grams of sodium? Okay, so just the steps here. Number 1, balance the equation. So will you please write out this equation and balance it? Take about 30 seconds. All right. So whenever we do stoichiometry in chemistry, you always have to start with the balanced equation. Now, sometimes the problem is already balanced for you. And in the problem, it will say that, like, in using the already balanced equation, yada, yada, yada. But if it's not, I double check it, you may have to do it yourself. Okay, the next step. Find the molar masses of the needed species. The needed species are the 2 things it names in the problem. The 2 things it named were salt, and that's NaCl, and sodium, that's Na. So chlorine is certainly involved in this process, but this math question doesn't give a crap about chlorine. So don't even worry about it. Are we okay with that? Don't do more than you're asked in the AP chemistry. All right. So do you, just be honest, raise your hand if you remember how to find the molar masses of things. Okay, that's 2/3 of you. So let's just quickly review. You look at the periodic table. You'll find Na, and it will have 2 numbers. Is it 11 on top on that one? Yes. 11 and 23. The big number is the molar mass. I don't want to show this. It's because I was just bragging how healthy I am.
That's a symptom.
Oh, yeah. Pride comes before the COVID.
All right, you still taste your Pepsi?
Yeah, I'm just joking. I just grew up with my throat hurt because I drink coffee and I hurt it. TMI. All right. Here's the chlorine. It's 35.5. So to find the molar mass of NaCl, you just add, you get 58.5 grams per 1 mole. Please remember it's per 1 mole. That will make life easier. All right, so coming back. So I got 23 and 58.5. So the first 2 steps. First, balance. Second, find the molar mass of what you're going to need. Step 2.
Wait, what?
This one. Step 1, 2, 2, 3, 4.
Oh, that's kind of funny. Oh, that is OCD.
That's a little bit.
It's okay. I have low standards myself, so I usually meet them. Okay. It's a great way to live, kids. Looking at number, step 3. Set up picket fence with given number and unit at top left. Okay. The picket fence is really just a line with some lines through it. Okay?
No one.
Yeah, it's a fence. That was not as good. It's just like that. That's where it gets the picket fence thing. Okay, here we go. So just please follow along. Set it up with, in the top left, with the given number and unit. Look at the problem. It gave me 36 grams of what thing? Na. Please be thorough, really thorough as we go through this. Like, some of my best AP students probably became accountants. And that's just because they are attentive to detail. They might suck at chemistry, but they're so into details, they're great at crap like this. Okay, now, sorry, with awesome stuff and opportunities to grow. My fault. Okay, now look, number 4, move the given unit down and right until that you have the unit you want. Okay, so what that means, look at the screen. It means I'm going to move grams of Na right here. Now look at the problem. What do I want to solve for? What unit? Grams of NaCl. You okay with that? Okay, well, I shouldn't ask, because I'm going to move on when you say yes or no. So, here we go. Now, please, grams of Na. Look at the screen. When I put grams of Na, I had it per what? 1 mole. I know I didn't put a 1 there, but I should have. So that means this ratio is for every 23 grams of Na, I have 1 mole of Na. Now look at the screen when you're done writing that. So I want you all with me for a second. Okay, now, step 4. Move the given unit down and to the right until you have the unit that you want. Are moles of Na grams of NaCl? No. So I'm going to move this unit over here. And I have mole of Na. All right, now, here's where the chemistry magic happens. Is there another ratio of moles of Na up here? There it is. Now, here it is. Please, 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 please be looking at the screen. This balanced equation shows me there are 2 moles of Na for every 1 or 2 moles of NaCl. Now, how did I know I needed NaCl? That's what I want in my answer. So I'm going to come back here. I'm going to say from right here, for every 2 moles of sodium, I get from right here 2 moles of NaCl. Now, don't at me that that's a completely worthless math part. I know, I don't care, but just trust me, it's not always perfect.
So you just did that from saying, okay, you have 2 moles of Na.
Right here.
Is that what, that's where you got that from?
Yep.
Okay, and then you just look over and you say, okay, 2 molecules of NaCl as well.
Yep. And so when I made this fancy presentation, you'll notice this piece is light blue. These were all light blue. And then right here, this is light blue. This step right here is called the ratio of coefficients. The ratio of your balanced equation that compares the moles of what you want, and that goes on top, to the moles of what you were given, and that goes on bottom. This is the step that requires us to have the balanced reaction. It's called the ratio of coefficients, and it will be involved in every one of our ticket pencils. If you didn't do the ratio of coefficients, then you didn't do the problem right. Okay. Now, I'm still not done.
So is the given always start in the top left?
Always, given, top left, always, always, always. Okay, will you take a guess with your line partner and tell me the unit of whatever goes down here? All right, good, I heard Reese. Moles, NaCl. Where did I get that unit?
From
Right here. They match. What must be on top? It's the only thing I'm left with. For every 58.5 grams of NaCl, I have 1 mole. Now, let's do our favorite part of math. If you look at the screen, I'm going to get rid of all of the units that cancel out. Grams of Na cancel out. Mole of Na cancel out. Moles of NaCl cancel out. And I'm left with just grams NaCl. Is that what I want in my answer? Yes. Okay, I'm going to do one more part of canceling out, and that is why type a 2 in my calculator on the top and the bottom. That would be a waste of my mind, right? So here we go. Now, we'll talk about this one in just a second, because honestly, this makes it easier. It's done. When we get this completed, you take all the numbers on top and you multiply them. You take all the numbers on bottom and you multiply them, and then you divide the two answers. So someone please take 36 and multiply it by 58.5.
2,106.
And then you divide that by 22.
Oh my gosh, I got the answer right. Hold on.
What? 91.6?
Well, 91.56521714.
Well, according to my significant figures, I should have just stopped at 91.
Thanks, I got it. 92. Or do you not around?
Yeah, over 92. Thanks. You idiot.
Wait.
Reset winning the game. Okay, I like this. Can we do this on chemistry? Nothing else.
I keep saying that.
Probably was that easy.
This is some of the hardest stuff you do all year. Not this problem, but what we're leading up to. Definitely.
I'm very sympathetic.
Hold on, let me see what's on the next slide first. Oh, that's all right. Okay. Okay. Murray said he got the answer right his own way. That's fine. I'm just giving you a tool that has proven successful. If you do it your own way, I really have no problem with that. Just it gets tricky. So just make sure your own way works. Okay. Rule number 5 says if you ever get stuck, then go to the end and work your way until you meet in the middle. So on the next example, we'll walk you through that. Okay. So how many grams of iron are required to produce 80 grams of iron 3 oxide? So we're going to balance the reaction. Well, that's tricky. You only gave me 2 things. Well, what must be the other reactant?
O2.
Oxygen. So Fe plus O2 goes to Fe2O3. And yes, in case you're wondering, you would have to be able to do that as a math. You should be able to read a reaction and be able to write it out and balance it. And I have the same 1, 2, 2, 3, 4, whatever. Okay, 4, 3, 2. You okay with that?
Yes. Take that.
All right. Now, find the molar masses of the species needed. So we need iron, and we need iron 3 oxide.
Make sure iron is there.
It's 56. It's 20.
So it's 56 grams per 1 mole. Is this one 160? You want to do that one yet?
56 plus 6. Oh, wait.
To get the lower mass, do you have to include like 2 iron and 3?
Yeah.
You do?
Yeah, you need 2 times the mass of iron plus 3 times the mass of oxygen. And I swear it's
That would
160.
be 160.
Man, who did that in their head? That guy must be really smart. Super smarter than Andy Ballou. Okay, so
What's his name? Andy Baloo.
Andy Ballou.
Well, never mind about him.
You know what I should have done? I should have done. I should have done Tom and Nettie Arbuckle.
Well, did you know that my mom's name is Shannon? Apparently you dated my mom and my aunt.
I remember Shannon. That's so bizarre. Is that weird? It's weird to me. Like, you get a cool one.
It's weird that like you have
You have some weird connection?
Yeah.
yeah.
What's Nettie's husband's name?
Brandon.
Brandon. What a loser. Just kidding.
Grace is about to go home and rat you out, Davidson. You're gonna get a long email the next
Brandon,
morning.
we don't have
I'm not appreciating you part of my life.
Wait, it's her mom.
No,
No.
my aunt.
Wait, can I just ask you ever kiss her ass?
No. Boyfriend kisses his girlfriend's sisters.
No, did they ever kiss my aunt?
No.
Yeah.
They did date.
Oh,
Yeah, oh no, that's what I'm saying. Yeah. If there were ring doorbells,
I
then we
kissed
might
her
have
hand, yes.
You have?
Many times.
Oh,
He dated forever.
I know, but like, ooh. I feel like we just had to get that out of the way, you know?
Many times.
Are you all okay? Sorry.
No, it's like fine. It's just like I just wanted it to be said, you know?
Okay.
I wanted it to be said.
Wanted it on recording.
Hey, spoiler alert, you're probably gonna kiss your girlfriend in college. I'm just warning you right now.
Wait, really?
Okay.
This is why I can't be a teacher.
Okay, I'm moving on. Just like Shannon did. No, it wasn't sad. It worked out so good. Here we go. Set up a picket fence with the given number unit at the top left. What's the given unit and number?
80 grams.
Of? Please, 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 please be thorough. If you put 80 grams, you don't know what goes down here. If you put 80 grams of Fe2O3, we know absolutely what unit goes down here.
Grams.
Of Fe2O3. These units, my friend, we hold these truths to be self-evident. That these units, they will always match right here. These will always match. These will always match. Okay, now, where is my proportion or my ratio that has grams of Fe2O3 in it? It's right here. There are 160 grams of Fe2O3 for every 1 mole of Fe2O3. Be super thorough for right now. So what unit must come down here? Mole of what? Fe2O3. Okay, now, pretend that you have no idea what goes next. And for some of you, that might not be that much of a pretend. So, not being rude, but we're going to say, all right, I don't know what goes here. So look, right here, if you ever get stuck, go backwards. So this is what I mean. We know the answer is what unit? Grams of Fe. Please look at the screen, and I'm going to say something to tell you. It sounds dumb, but the unit, look at the screen, the unit at the end is always the unit at the end. These will always match each other. And then I can look up here, what ratio do I have that has grams of iron in it? For every 56 grams of iron, I have what other piece? 1 mole. Oh, go on.
Hi, sorry, I didn't want to interrupt.
It's okay.
When you get a sec, will you share me the testing, or is it the one you used last year?
It's a copy. I have shared it, but I can reshare it through your email.
I'll look again and see if I can see it.
Yeah, look for, it says Elemental Hotel 2020 or
If
something.
I need it, I'll come find
Yeah.
it. Sorry, I
All
should
right.
have Carter.
Okay.
It might be because I referee.
Yes, sir.
So just by looking at the word problem, you can figure out what here. Or I guess, yeah, because you're trying to find the grams of FTE, but you already know that'll be the last one in the condenser.
Yeah, because it's like a map. I'm giving you where to start. I'm giving you where to end. You just have to connect them. Okay, so please look. Based on this right here and a truth that I'm holding self-evident, I know what goes here. It is what? Mole of Fe, because these always match. These arrows could have certainly been written both ways. These match, these match, these match. Okay, now I need to find something. I need a number that goes here and a number that goes there. Where can I find a mole-to-mole ratio? All right, my balanced equation in front of, look at the screen please though, because some kids screw this up. In front of just Fe is a 4. In front of all of Fe203 is a 2. Yeah, now let's go to town. Let's cross out everything I can. I can get rid of the 2 and reduce the 4 to a 2, correct? And then I get rid of all of these units that I don't want in my answer.
If you don't want to simple, like reduce it, you have, like,
No, you don't have
give you the
to.
same answer.
Yeah, your calculator will do the same.
Yeah,
It will just laugh at you.
I like being laughed at.
Okay, yeah, no, it'll be 100% fine. So now, the math, you type in every number across the top. So 80 times 2 times 56. And then you divide all of that by 160. Now, most of you in AP will have a calculator that can do parentheses. Multiply the top and then type in the denominator in parentheses and it'll be just fine. But if you don't have one that does parentheses, you A, should borrow one of mine, or B, write it out specifically like this and then do the math like that. Okay, did anyone type this in?
Yeah.
What was it? Well, that was pretty awesome and boring. That was predictable. I could do that out of my head because look, this is 1/2 times 2, so that's 1 times 56. My bad.
I was gonna say, it's like it's
So will it always follow this like 4 section thing, or will we have ones that are?
Sometimes it's shorter. We don't ever go longer in this class, but you definitely can. Sometimes it's shorter, and the reason you would know it's shorter is sometimes it will just ask for moles. So if this problem said how many moles of iron, we would not have needed this step. Because we would have been that one right there. But 99% of the time in AP chemistry, it will be one with the 3 vertical lines. And that's when we're going gram to gram, which we will do an incredible amount of. I sense that the class is over. Is that right?
Yeah.
You take a picture of this and see if you can do it. Is it legible enough?
Someone wanted to select on the group homework tonight.
Yeah, just give it a shot.
I don't even know.
Someone take a good
Does
picture.
that help?
Can you make it like instruction figures?
Okay, well, not much bigger. But it takes me off. Okay, try this and we'll look at it tomorrow.
Right, David said, I'm starting to realize that I can understand chemistry. It was just those beginning few weeks for me. Now I